We all know that the oceans play a critical role in our climate and weather, but not everyone knows that a quarter of man-made CO2 emissions are taken up by land every year, while an equal amount, 2.6 billion tons, dissolve at the sea surface to be transported into the deep ocean. Slow-moving deep ocean currents will eventually reach the surface again, but this may take 1,000 years or more, so that this CO2 is locked away for that period. This means that while the proportion of CO2 in the air is increasing and causing global warming, this increase is only half of what it would be if we didn't have the land and the oceans. We might think of this ocean CO2 uptake as a cushion which reduces the impact of our emissions. It softens global warming. But is this likely to continue, or might it stop? Given how important this process is for moderating global warming, it is imperative that we find out. A new research program called Radiatively Active Gases from the North Atlantic Region and Climate Change, or RAGNARoCC for short, aims to do just that. It is funded by the Natural Environment Research Council as part of its Greenhouse Gases UK project. RAGNARoCC is a 5-year project which aims to understand ocean CO2 uptake in the North Atlantic Ocean. RAGNARoCC aims to quantify the amounts of greenhouse gases which dissolve in the surface, their transport to and storage in the deep ocean. This knowledge will feed into climate models, which can be used to predict likely climate outcomes and inform relevant policy decisions. But how do climate models work? Brian King from the National Oceanography Centre, Chief Scientist on a RAGNARoCC cruise.
I think most of us are familiar with the idea of weather forecasting, where you make an inspection of what the weather is now, and then a computer that understands the physics of changing weather will try and predict what it's likely to be like tomorrow. We do a very similar exercise with climate. We try and gather information about what the climate is now, and then computers that simulate the physics and chemistry of the atmosphere and oceans will try and predict what the climate might be like 10, 20 or even 50 years from now.
The North Atlantic is the single most important region globally for the uptake of man-made CO2. And in the North Atlantic, we have deep water formation, where cold, salty water sinks to the bottom, taking CO2 with it. This process is repeated year on year, so that last year's deep water is pushed south along the entire length of the Atlantic and eventually into the deep Indian and Pacific Oceans. During RAGNARoCC research cruises, we measure the concentration of CO2 and other greenhouse gases both in surface water and in air. We also measure their concentrations in deep water. By measuring the concentration of man-made traces, we can tell the age of this deep water, so when it was last in contact with the atmosphere. For example, we test for CFCs, a class of industrial gases which were used in aerosols and refrigerators and dissolve in seawater. These were first developed in the 1930s and widely used from the 1950s onwards. If a sample of deep water does not contain any of these, then we know that it was last in contact with the air before this period. By using a combination of different CFCs and knowledge of their emission history, we can build up a picture of where and when deep water formation took place. In turn, this helps us differentiate man-made CO2 from background, or natural CO2, which is abundant in the deep ocean. We're also looking at the transfer of greenhouse gases across the air-sea interface and into the deep ocean, and finally, all this information is used in computer models. If the models can match the current observations and those in the recent past, then we can be confident that they can predict the future. What are we hoping to achieve through this project?
So one of the things that we are hoping to have learned by the end of our project is how the ocean's changing. We know that this part of the ocean where we've been studying has already got one of the highest concentrations of greenhouse gases of any of the world's oceans. By comparing our new measurements with the old ones, we'll be seeing how that's changing. We'll also be trying to understand why it's changing.
How might this information be used, and who might use it?
The reason we're doing this program and trying to achieve this understanding is so that we can help with providing more reliable predictions as to how the Earth's climate is going to change. There's a general understanding that the fate of carbon dioxide and the other greenhouse gases is going to affect the atmosphere. It's going to affect how much extra warming there is because of the trapping of heat by the carbon dioxide layer. So the people who are going to use these data first are people trying to do numerical simulations to predict how climate is going to change. And the customers for that information are policymakers, governments, the Department of Energy, the Department of Climate Change, even the Department of Agriculture, who need to know how the climate is going to change so that they can predict future growing patterns.
RAGNARoCC has brought together a diverse range of scientific expertise to ensure we gain a better understanding of the role the oceans play in the cycling of greenhouse gases. It will enable early warning, which in turn will facilitate policy decisions.